Hello students, welcome to Engineers Academy. Do hit the subscribe button if you are here for the first time. Now let's solve this problem which says that two individuals are attempting to relocate a sofa by applying forces in the indicated direction. If F1 magnitude is 500 Newton and F2 magnitude is 350 Newton, determine the vector expression for the resultant R of the two forces. Then determine the magnitude of the resultant and the angle which it makes with the positive x-axis. So we have to write the vector expression of the resultant. So we have to write R vector and Rxi plus Ryj. And remember that Rx, the scalar component of the resultant in the x, will always be equal to the vector sum of the x components, or we can say that if we add the x component of both the forces, so f1x plus f2x, so this will give us the scalar component of the resultant in the x, and similarly ry will be equal to f1y plus f2y. Or we can do it in other way around. If we write f1 in terms of its I and j components, if we write f1 equals to fxi plus f1xi plus f1yj, and similarly if we write f2 vector, so that will be f2xi plus f2yj, and then by adding them, if we add them, then this f1 plus f2 will be equal to the resultant vector, and here we will add the I components and we will add the j components. So this is the method. So we will have f1x plus f2xi plus f1y plus f2yj. So for this I have drawn the free body diagram. As you guys can see that f1 is only acting in the positive x direction, that is in the horizontal direction. So f1 is in the positive x direction and it has a magnitude of 500 Newton. And similarly f2 is acting in this direction, which is making 60-degree angle with the horizontal. So this is that f2. So in order to get the resultant, we have to join the tail of f2 with the head of f1. So we need to add them by head to tail rule. So f1 plus f2 by head to tail rule will give us the resultant R. So first of all, we need to write f1 as a Cartesian vector in terms of I and j components. So we can say that f1 vector. So as we can see that f1 is acting in the horizontal direction, so its vertical component is 0. So this means that we can write f1 is 500 I, because the whole force is only acting in the x direction, so the whole magnitude is in the I direction. So we can say plus 500 I, because 500 is in the positive x, minus, and there is no component in the y direction, so we can say 0j. And similarly we need to resolve this f2 into its components. So we will have one component in this direction, this one will be f2x, and we will have f2y. So we can say that this will be f2x and this will be f2y. So now we can say that f2x will be equal to, since the angle is made with the f2x, or we can say that f2x is adjacent to the angle, then f2x will be the cos component, as we have discussed earlier as well. So we can say that f2x will be f2 cos of 60 degrees, and now f2 is 350 cos of 60 degrees, and f2x is in the positive x, so we must write positive sign with it. So we can say that f2x is 350 cos of 60. So this gives us f2x, the scalar component of f2 in the x is plus 175 Newton. And similarly we can say that f2y, so if the f2x is the cos component, then f2y is obviously the sine component, so we can say that this will be f2 sine of 60 and f2 is 350. So 350 sine of 60. So we can say 350 sine of 60. This gives us approximately 303. So 303 Newton is the scalar component of F2 in the y direction. And again, as you guys can see that F2y is also acting in the positive y direction. So we have to put plus sign here as well. So F2y is plus 303 Newton. So now we can write F2 vector. So F2 vector will be equal to F2x. So F2x is 175 and plus F2yj. So F2y is 300 plus 303j. So this is F1 in terms of I and j, and this is F2 in terms of ij and k. And similarly, we need to add them. So we can say that we need to add both of these vectors. So F1 plus F2 is obviously the resultant. So we can say the resultant is equal to, now we can say that we can add only I with I and j with j because this is the vector addition. So we can say 500, or we can say plus 500 plus 175 I plus here F1 we can write it as plus or minus, doesn't matter, right? So 500I plus 0j, right? So we can say plus 0 plus 303j. So the resultant is equal to, so 500 plus 175 is 675. So 675I plus 300j. So this is the vector expression of the resultant. This is the vector representation of that resultant in terms of I and j. Or we can say this is the Cartesian vector representation of the resultant of those two forces which are applied to the sofa in order to relocate that. So we can say this is our x. We can say that the scalar component of the resultant in the x is plus 675 Newton, and the scalar component of the resultant in the y is 303 Newton. Now here in the diagram you guys can see that the resultant will have our x component in this direction, which will be equal to the sum of 500 plus f2x, and then we will have our y in this direction. So we can say that if the resultant is acting in this direction, so we will have our x in the positive x direction, and we will have our y in the positive y direction. Now our x is 675 Newton and our y is 303 Newton, and we have to find the resultant magnitude. So we can use the Pythagoras theorem, and we are also required to find the angle theta of the resultant with the positive x-axis. So we can say that we need to find this angle theta as well with the positive x-axis. So now we know our x and our y. We can find the magnitude of the resultant by applying the Pythagoras theorem. So we can say that r square will be equal to r x square plus r y square, and by taking the square roots on both sides we will be able to find the resultant magnitude. So the resultant magnitude is r x square, which is 675 square plus 303 square. So this is equal to 675 square plus 303 square. This gives us 739.88. So we can say it is approximately 740 Newton. So this is the resultant. And in order to find that angle theta, we can apply tan theta to this right angle triangle. So we can say that tan theta is equal to the opposite side divided by the adjacent side, so which is rx. Ry is 303 Newton and rx is 675. And if we take tan inverse on both sides of equation, we will have tan inverse 303 divided by 675. So we can say tan inverse 303 divided by 675. So the angle theta, which the resultant makes with the positive x-axis, is 24.17 degrees. So the resultant magnitude is 740 Newton, and it is making 24.17 degrees with the horizontal, or we can say with the positive x-axis. Now there is one another method to find the resultant magnitude and its angle with the horizontal. And that method is, you guys can see, is by using the geometrical method. Now as you guys can see that this angle is f2 is making a 60-degree angle with the horizontal. This is 60, so the whole angle is 180. So this angle is 120. So we can say that this angle is 120 degrees. The angle between the tail and the head of F1, where we join those two forces, this angle is 120 degrees. So we can use the law of cosines. This is the geometrical method. We can use law of cosines to find the resultant magnitude. So we can say, according to law of cosines, we can say that r square is equal to f1 magnitude square plus f2 magnitude square minus 2 times f1 f2, and the angle which is in front of this resultant. So in order to apply the law of cosines, we must know the angle opposite to this resultant. So that angle is 120. So we can say 2 times f1 f2 cos of 120 degree. And if we take the square roots on both sides of equation, we will be able to find the resultant magnitude. So resultant magnitude is equal to f1 square. F1 magnitude is 500 plus f2 is magnitude is 350 minus 2 times 500, 350 cos of 120 under the square root, and this must give us that same 740 Newton magnitude. So we can say 500 square plus 350 square minus 2 times f1 into f2, 350 cos of 120. And as you guys can see, this is the same, approximately 740 Newton. So the resultant magnitude is 740 Newton. And similarly, we can find this angle theta. Once we know this resultant magnitude, which is 740 Newton, we can apply the sines law. So by sines law, we can say that sine of theta divided by the magnitude of the opposite side. So the opposite side to theta is f2, which is 350. So sine of theta divided by 350 is equal to sine of 120 degrees divided by the resultant magnitude, the magnitude of the opposite side, which is the resultant, which is 740. We can say 740, right? So we can say that if I multiply both sides of equation with 350, this will cancel out and we will have sine theta equal to that. And if we take sine inverse on both sides of equation, we will be able to find that theta. So we can say sine inverse of sine of 120 multiplied by 350 divided by 740. So this is equal to theta is equal to 24.18 degrees, which is about the same. This is 24.17, this is 24.18. So this is how we can find the resultant. In terms of its I and j components, this is that resultant, 675i plus 303j, and this is that angle theta which the resultant is making with the horizontal. And similarly, we can use the geometrical method to find the resultant magnitude by using the law of cosines, and finding the angle theta by using the law of sines. So I hope all this discussion will help you in your learning. Do subscribe Engineers Academy for the solution of such more problems from Engineering Statics by Meriam and Kraige 8th edition.